My name is Shreya Muralidharan. I'm a researcher at the National University of Singapore. And this research was conducted in Singapore in collaboration with the University of Texas at Austin and also the Construction Industry Institute. We were funded for this study by the Singapore Economic Development Board. So let's straight away dive into the research background. I think Mr. Karanjawala actually helped me set up the basis for this study on how important productivity is. So thank you for that. And so labor productivity, as you may know, is key to the profitability of any construction sector, and particularly so for the petrochemical industry. Especially in the case of Singapore, 34% of the manufacturing output comes from the petrochemical sector. And the labor costs are the largest share of the manufacturing costs in Singapore. And so need for adopting productivity-driven growth in Singapore, considering the influx of foreign labor and also the aging issue in the population. So when we went back to literature to identify the various definitions of productivity, we found that usually it's a ratio of the physical output that has been produced over the total cost of labor, equipment, and material in the name of total factor productivity, or partial factor productivity, which just takes into account a single cost factor, and also labor productivity, which is a key index where the units of physical output is ratioed with the number of actual work hours spent. And finally, we came into this particular concept called work sampling, which basically means that one has to observe and sample the workers on a particular day, and that kind of gives a representation of the workers' behavior on a typical day. So this can be considered as an index of labor productivity, and there are several definitions. However, we couldn't find a single definition which was common for all petrochemical projects, that is construction, maintenance projects, as well as shutdown turnaround. So that gave us an additional motivation for this study. Moreover, lean construction principles emphasize on two key aspects: continuous improvement as well as reduction of waste. And to achieve so, we need to understand the current productivity pattern. And as a result of which, there is a significant need for a common method of productivity measurement which can suit all project types and also all companies and countries, so as to facilitate benchmarking. So therefore, we set out to, with these research objectives, to define a common productivity measurement method for all petrochemical projects, and also assess the labor efficiency in Singapore as a pilot, and to investigate the reasons for non-value added work hours, and also recommend mitigation strategies which can improve the productivity. So, the method that we chose was activity analysis. It is an extension of the work sampling method, wherein there is a continuous process of measuring and improving the amount of time that craft workers spend on actual construction. And this involves observation and categorization of labor activities at a plant site, so which is an extension of work sampling. However, it is slightly more detailed than work sampling because it identifies key issues and provides quick and actionable feedback on workers' performance. I will explain how it does the same in the next slides. And the end, there is no disruption of plant activities. Since the process involves mere observation and categorization, it doesn't disrupt any plant activities or does not involve any interaction with the workers themselves. So, why did I say that activity analysis is an extension of work sampling? Activity analysis actually categorizes the worker's activity in a typical work day into 7 categories, namely direct work, which is installation or demolition, which is actually contributing to the project. Waiting, this waiting could be for any reason. It could be for permits, for inspection, for material, for tools and equipment, or for any other reason. And also, it categorizes safety talks, toolbox meetings, and other preparatory work related to the project as preparatory work. Material handling as the time which the workers spend on moving the material either from the warehouse to the actual site or for moving the material from one part of the facility to another. Travel, where if a worker is observed to be traveling without any tools, material or equipment, just moving back and forth on the project site, that could be travel. Tools and equipment would be to adjust any, if a worker is observed to be adjusting any tool or equipment, that would go under this particular category. And personnel, which is ideally the waste activity that we aim to reduce, is taking unscheduled breaks or any such activity which doesn't contribute to the project as such, but is related to the worker taking like unscheduled breaks or something like that. So based on these categories, we say that we take the samples of the workers on a particular day. So activity analysis follows a multinomial distribution because there are so many categories of worker activities involved. And hence, we look over this particular formula for calculating the minimum sample size that needs to be taken so as to achieve statistically significant results. And the key advantage of activity analysis is that the observations per hour may be collected over 2 to 3 days. Say the formula probably gives me that I need to achieve about 160 observations per hour for me to achieve statistically significant results. Then this 160 observations can be taken during the same time frame over 2 to 3 days. So it's easier for me to take it, and therefore it overcomes human limitations in observation. So activity analysis is a continuous methodology where we plan the study of understanding the job scope and also the number of workers who are involved, and decide on the minimum number of observations that are required for us to study the productivity. And then we go into the site to sample by observation by moving through random predefined routes so as to observe the workers and categorize their activity. Then the data that we obtain from these samplings, we move into the analysis where we identify key issues which are related to low productivity in that particular job. And based upon these key areas, we try to plan improvements which can improve the productivity by mitigating the productivity barriers. And we try to implement these improvements in consultation with the plant owners and contractors based on cost and schedule. And then we do this all over again. So it is a continuous process that we undertook. So our methodology was that we customized the activity analysis methodology to suit maintenance and shutdown turnaround projects. In the case of Singapore, maintenance and shutdown turnaround projects are more in the current context due to the low oil prices. So this was important to us, and also to suit the Singapore site conditions in terms of the owner-contractor relationship and everything. So we also developed a specialized data collection tool, which is in the form of a tablet computer, which can be taken through petrochemical plants. It is safety certified, and then we use this data collection tool to collect data at 5 major petrochemical plants in Singapore. So we did a first round collection of data in 10 projects, which comprised of 3 construction, 3 maintenance, and 4 shutdown turnarounds. And in the second round, to validate the improvements of productivity, we moved into the second round with 7 projects with similar scope as that of the first. So this is a snapshot of how the data collection tool looks like. So there is a setup for information about the project and the plant and the contractors involved. And there is an observation setup which takes in details about the location, the project type, as well as the weather, and also the number of workers involved in that particular job. And this allows us to calculate the minimum number of observations, which can therefore help us to achieve statistically significant results. So then this is our final screen, where this is the screen that we take in through the plant and categorize the workers' behavior by observation into any of these categories just by merely tapping the screen. So this helps us to achieve the number of observations by looking at this particular bar there. So you can understand the minimum number of observations as well and calculate the results. So in the first round, we understood that the overall direct work percentage was about 29.5% for 10 projects, and the workers spent a significant time on preparatory work, waiting for various reasons, or even travel. So when we look by project type, construction projects have the highest, had the highest productivity as compared to maintenance and shutdown turnaround projects. And this was more interesting to us because this construction projects, there's always the motivation for workers to work harder or the contractors to motivate their workers to achieve higher productivity. But that was not the case in case of maintenance or shutdown projects. So looking at the hourly results, we could see that the workers spent a significant time on material handling during the hours before lunch and after lunch. And there was a significant amount of waiting and traveling in the beginning of the project. And also, there was significant amount of traveling around lunch hours. Hence, we noted some key observations: significant worker time spent on travel, material handling, and preparatory work. Waiting, especially for permits and instruction, was high in the first hours of work start. And therefore, we ended up with recommendations such as transportation, placement of the cafeteria nearer to the work site, using innovative transport systems such as battery-operated carts to handle material from one part of the facility to another, utilization of weather delays for toolbox meetings and safety talks, and permits, where we recommended the early issue of permits about 15 to 20 minutes before work start so that work could actually start on time. So we conducted a second round of activity analysis to validate whether there is an improvement in productivity after implementing these mitigation measures. And we could see an improvement in the direct work in these 7 projects with similar scope. So, and also a reduction in the waiting time, traveling time, and personal time nearly halved. So this gives us validation of a productivity improvement. And looking at the hourly results, we could see that the first hour of work significantly benefited from the mitigation measures which were implemented, and so did the particular hour after lunch. So this gave us more motivation to conduct further studies. Considering the project type, we could see that construction projects were the most easiest ones to adopt these kind of recommendations as compared to maintenance projects. That's the reason why maintenance projects experience a slight improvement, whilst construction projects experienced a significant improvement. And based upon all of this, we were able to present to you that a novel activity analysis method has been developed, particularly with a focus on maintenance and shutdown turnaround projects, which are seldom studied. On-site labor efficiency were assessed at 17 pilot projects in Singapore, and we identified the barriers as well as the mitigation strategies to improve productivity. And this, we believe, would be a pilot study which would provide a basis for assessing and benchmarking labor productivity in the petrochemical industry across all projects. Thank you very much for your attention, and hope you have a good day at the conference.